So later I can show. So from galley there will be some grease trap over here. Okay, running out of battery. So from galley we will this grease trap. Gray was should go directly. Okay, this is for training the grease trap when you are going to clean it. This one 010V. Okay, open this. Most of the heavier particles due to density will settle here and water will come in and go. And then on toilet. Oh, okay. Okay. So I don't want it to go to collecting line. I wanted to go to sewage. Okay, so this galley water is we have a direct overboard line. That's okay. It's good. Soil main on. Okay. 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 So this is a soft flushing. Okay. Discharge valve. Restores, like check valves and all that. Okay. Very good. Okay. Okay. Auto, auto, auto. Anyone auto. Treat. Air pump. Well, Rajan. Dot. Start. Auto. Full time. High level. Okay. Okay. Starting fire, I guess. Okay. What is our bilge water custom? We have a article for oily waste pump. Clean water discharge. Clean water discharge for ethics to go after CHS overboard. Okay. This is coming from, I think so. Refer at AHU and into that scavenge drain. The MSG cylinder drain. Okay. The next is most probably this. The water separator after discharging turbocharger. This water separator from there. Okay. This one is for main valve. Okay, third only. Sludge I will show. Start firing now. Okay. It stopped for some reason. Okay. So basically system. We have to start our heating. Heating you can start from here. Stop. Let's see, stop. First you need to go to auto. Start. So you can start the stack. Okay. Start this transfer pump. You can just click on it and start. This transfer pump will start. Filling pump, sorry. Then this is circulation pump. Okay. Circulation pump ID. To start, I'll start. But diesel ID is clear. This is return for the pump. Okay. To fill the stack. Okay. Sludge pump first. Transferring the sludge. We don't have much. So we have sludge solid waste. So I need to put the sludge. So I will do. Okay. You see, this is started to purge. So here basically temperature will increase. This is from 850. It will switch to sludge. Let us let the temperature rise. The generator first. You can see this is already risen. Which is already around 480, 500, 35 around. You can see now it is working on sludge alone. Our diesel pump is stopped. See if I align fuel oil pumps. Incinerator tank we have incinerator and geo tank. And geo drain tank. Okay. I want to send it to this tank. Geo trans. Fine. Okay. Check on geo transfer. MGO transfer. Wait. Oh, there it is. MGO service tank. Oh yeah, this is the storage tank. Okay. Incinerator. Oh, okay. Okay. So told you about this incinerator. Sludge. Bilge water. Yeah, where is this OWS? Solid water separator. Separate. Oh, this was oh, okay. Let's see if I can run this. Oh, bilge water system. Primary bilge tank. Oh, we have this from oily bilge from. Oh, this water can go back to the bilge. Oil can go back to this flush tank. Okay, this is all right. For this, I can set it to oil to bilge tank. Okay, this one is. Okay, this is going to. I will be separated. Okay. What the hell? This falling. Okay. Why is this not getting on? Okay. I have got out of them. This is all proof. In this solenoid all goes back to oil used. Yeah, those kind of. Yeah. So, okay. But to is relief on. Okay. Okay, let's go back to the first channel. Water go to overboard. Okay. Okay. 0.4 here. All the water is going to overboard. This is good. Okay. This system is good. Okay. So basically this stuff okay fine. Perfectly fine. Okay. So this is okay now. Now we'll go towards this. Now what I will say, changing our boiler to gas and generator to the gas. So first, the first step is simple. First, we are going to enter this whole line. First, we'll just pump in the nitrogen all this time and enter the system. You can just keep an eye on this panel, the walls, when it does change. You can see various walls will open and close. This air, this is solenoid walls open. This is air, I think air piston type or diaphragm type. Okay, first we'll do is manual button. You can see this wall is So we are filling in nitrogen to this wall. You fill this. Okay, so our inerting is completed. So now we are going to go for leakage test. Let's see how you start on my leakage test. You see the timer has started. Okay, so it has not changed. Okay, so now if you can see gas pressure in the system. So now we can go and change it. So how you change it? It's simple. That will be number three. Okay, you can see this LED is lighted up, engine ready for gas mode. So what you can do is you can just request gas mode, and you can see operation diesel 2 seconds. So it will start gassing up. You can see now this is running on second fuel. Now you can see the gas is going to number two generator, main engine and no generator. So now we are going to go for my boilers as you can see. I showed one A just to show how to change it over to gas. Now we can go to AB boiler. The boiler will not automatically cut in because now we are using EGB because our demand can be met with EG. Only Only the demand is for this FGSS to heat up this gas. For here, when we are using where it is this one, this is where we require steam mostly. As when we are running, most probably we will not ever stop the boiler. Maintenance on steam system is very difficult when it is when we are running on when we are middle of the ocean and we are running on gas and we require to run gas. Maybe some walls are leaking. We cannot isolate the system that time. So now we'll go where is okay. Okay, knowledge. Ah, the gas. Okay. So basically simple. We need to start this. So okay. Okay. First. Mama started off. Pre-play. Vaginas. Okay. GBU ready. Repressurizing. On. Okay. See the flame is blue. The pressure. Oh. 9.60 bar. Okay. On a stop fire. Let's see. Okay. Post project. Okay. So this is how we change it over to gas. Okay. What else was left? Gas. Nowhere. Okay, already running. Okay. I already shown this. Oh, gas system. E. Air and refrigeration system. Okay, let me explain. I would have done how to fill it. So basically, this. Okay, so this one is a sightless. This is very important. This can tell you if you have any moisture or if there is the charge in the refrigeration system is low. Where you can see this. This is receiver, and this is expansion valve. Okay, so this last time I think so I would have not told about this heat exchanger. Now what this is heat exchanger is doing is when it is going this hot reefer gas, and this is cool. So basically this is a reefer gas which is hot, but it is still a cool reefer gas. So what here it is doing is when it is this low pressure uh, cool gas is going and going to this heat exchanger, and from here this liquid is coming. So what here is doing, it is doing the subcooling of this liquid refrigerator is going to this evaporators. So what it will do is go this will give its heat. So no, this will take the heat from this liquid refrigerant. So what will happen is it will do some degree of subcooling here and it will get heated. So degree of superheat will increase and then it will go to the compressor. Right, to compress this oil separator is there to separate the oil from the refrigerant. It is very important. Otherwise, this is not working properly. This whole piping will be filled with oil, little bit, and then oil will act as a insulator. So that's not good. So this should be working fine. And also this one, air and dry filter. And this one over here is this one is an accumulator. Simple. The gas, the liquids gets collected here. The gas come and gets flown from here, and uh, gas come and it passes from here and goes to the compressor. Capacity control. Is capacity control depends on the this suction pressure. So if the suction pressure is more, let's say C2301, then I think so. The this semi-hermetic type of compressor as well as so what happens is this there are different cylinders. Each cylinders have their own suction valve. So like in air compressor, if you keep the suction valve open, so there is no compression, there is no load on the cylinder. So nothing is happening. It is what I can say. It is there is no load on that cylinder. So there is a line basically from this logo line. One line goes towards a pin is there, a sleeve is there. Above the sleeve there is a pin. So the lower will go and the pin will lift up. When the spin lift up, what it does uh, it opens the suction valve, and due to which there is no compression. And this lube oil, which is going to lift the sleeve, which lifts the sleeve up, it's controlled by solenoid valve, and that solenoid valve is controlled by the suction pressure, which we see, and that's how capacity control is done. And you can see for this, here it is. This is dry provision and provision in vegetable room. You will see this special kind of valve. So what is this valve? It is throttling the flow. It is throttling the flow such that the pressure air is moved. You know, if you reduce the boiling point pressure, the boiling point reduces. But we have to maintain the temperature 9, 5 degrees Celsius. So we have to make sure that the pressure air does not fall below. the- See, according to the pressure, there is a temperature, boiling point, or you can say saturation temperature. So you have to keep pressure over here such that in the evaporator coil, you have to keep it such a way that the boiling point or the saturation temperature of the refrigerant does not fall below 0 degrees Celsius. Because it 0 degrees below 0 degrees Celsius, because in vegetable room and we have to maintain kind of a moisture, and if moisture is there, there will be icing on evaporator. Also, we require the moisture because we cannot maintain minus temperature over there because we don't want uh, that vegetable and fruits to lose its water content, so it will get spoiled easily. So this will maintain the pressure, high pressure around here, due to which boiling point is of the refrigerant fluid is above 0 degrees Celsius. So above 0 degrees Celsius, it is getting boiled. So it will maintain 2-3 degrees Celsius above its temperature. So it is like this is the theory all about this refrigeration system. This one is important. 2 by 3 or 1 by 3 should be always filled up. Okay, fine. Okay, and there is AC system is there. No? Oh, here only. RSP, pump room. Okay, okay. You can see uh, the main difference between the you can see refrigeration system and AC system. You will find is that the pressure you will maintain a higher suction pressure because you can see we are not maintaining a temperature here below. You cannot actually maintain below 20 degrees Celsius. So whatever comes may, we have to maintain the suction pressure such that the saturation temperature is always above 0 degrees Celsius because you don't have a defrost system. On AC systems, you don't have a defrost system. So we don't have we make sure that the pressure, the refrigerant type we use over here. So we have to make sure that whatever pressure is here, the corresponding boiling point of that refrigerant does not fall below 0 degrees Celsius. And we don't require that much low pressure because we are not cooling our air for what I can say to 2-3 degrees Celsius. So you can see always you can see 6 degree, but in refrigerant we need -80, -20. So you'll see the section pressure very low. Basically, the refrigeration side of the AC and the refrigeration system is same. Now here you can see this. So this is air is coming. This is I think so. This is filter. Oh, this is a humidifier. This here we spray the steam. Generally we don't use this. We use water. It's okay. And this steam is for heating. and this is going to distribution. This is a humidity sensor. This is temperature sensor. You can see this is going to this heating section, and this is going to this humidifying section. Basically, we have to maintain 30 to 70% of relative humidity, and the capacity control is same in both. For concept is same. Okay, and in some okay, so this is about AC system we have discussed. Now, what is it? Let's see. This I'm not very sure, but I can explain some. You can see this is called a servo pump, and this is called steering air pump or main pump. You can see this is bidirectional, and this is single direction, and this line variable flow. I think so. It's variable flow. Okay. So what this pump does is whenever you start this servo pump will start first, and what it will do, it will go here. You see, it activate this valve. This is unloading valve, and from here it is going. I'm not sure. I've not studied this. This is a relief valve. And then this is going here, and it's activating this. You see, now you see this is going and activating this. This is a non. This we are stopping the flow. You see, now we can flow. This is a non-random check valve. So basically, oil flows from here. This is solenoid controlled. But this one, to activate this, we need oil pressure. And when oil pressure is going over, you see this is not, this one is closed. You see, now from oil flows from here, goes there. This line, I'm saying this line. Returns from here. This much I know. I can't tell in full detail. This much I have studied. I observed, I have not studied. This is how it works. So, okay, I will teach how to take this in emergency steering. Oh, we have this. Oh, no. Wheelhouse. See? Okay. 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 See. Why it's not okay? Okay, let's check now. Okay, now I stop the autopilot. Okay, so like, oh, see, sorry, no. Oh, Lingman, port. Okay, wait, check. Port on auto. Wait, okay. So when you need to manual control, you need to do only. Okay, I see manual. Baseline, you will go just off the system. Now we go to steering. Lower control. The server form will be running. Okay. The number one is still working. Okay. Basically. Okay. Now what we are going to do is we are going to switch this to steering gear. We are going to now you can use this. This is unloading all. Oh, sorry. Now you can use this horseshoe type. So this is how you take manual control. I'm just trying like this only. See, this is isolation. All this. Okay. Oh, see this. Just check this direction of the pump. Now this lower shade. Now I'm going to put when you're going to put this from here, the oil is going from here. And one line is going from here. But this line is stopping. Okay, this wall. You see, from here it is going. So we can operate both the rams. Yes. Otherwise, only one ram will be there. Okay. This is basic. It's going here. This pump, I think so. Okay, this valve is, I think so. I forgetting what the use of this valve is. See if you. Okay, so what this valve is this. Now, when you are running the system, you see. Okay, I'll move the board. You see, the oil is flowing from here. Okay, one oil goes here, comes here, goes from here, returns back. But one this valve goes here. This check valve is here. This check valve prevents what? This check valve prevents this oil pressure from this system going here and running the pump in certain direction. So this is kind of a safety. I'm forgetting the name of this valve, but this valve, particularly this valve, stops the oil to going to the pump, back to this pump. That's the basic use. See, it's blocked now. It'll go like this, after this, and then like this it will go and it will go back. Okay, so this is basically the system. Now to change over, we can just turn on or put it on. Well, yes, take out this. Basically, you have to update this only, loading one, whichever system you're using. Speaking of now, we'll go to the local control. Just switch on the auto power for both. Okay. So that's not steering. You see number one is right. Put on manual. Okay. You see, steering your room is still. Okay. Put it on wheelhouse. Okay. So now we have taken off. No, no, mid shape. You can put an auto. Oh yeah, that's it in this. Afterwards you'll see. This much is only there to show in this. HCR. Oh, HCR is there, no? Okay, okay. HCR system is the next. Okay, I will show HCR how to start. Now we'll start the SCR system. We'll start with main engine, then we'll go towards this. We then we'll go towards AE. So here is this catalyst system. We are injected urea from here. This is a bypass valve where system will be running. So basically the main engine has to run in a certain condition, certain load and certain exhaust temperature. This burner is to increase the exhaust temperature for here the reaction to take place. Here we are running and this air is for soot blowing this mixing pipe and this catalyst element over here. Okay. This catalyst I'm forgetting a little bit of the theory, but this is how we do it. Okay. We'll put it on remote. And that's also on remote. So this way I have opened because when we're using this we'll utilize. So from here storage tank it will go. Okay. That's all things are good over here. And basically main engine should run on certain load for exhaust temperature to be certain in certain range, then only it will work. Okay. So This is the burner section. So this for fuel, this system should be on. It's okay. This diagram you will see have forwarding what catalyst does. This is how it does. Compressed air. This also blowing is also blowing the suit. You see there are various solenoid valves. 152 ppm, 152 ppm. It will be very high if you use this diesel oil, but okay. Okay. The first you need to select prepare tire 3. As you can see, select tire 3. Okay. Z tire 3 is active. As I told you, this bypass all closed and this was you see 12.2 ppm, 153, and you can see the temperature also. This is because of the fine tuning we have. You can reduce the exhaust gas temperature. So it's 177 when it is reaching after EGB. I don't know, I think so it's before EGB. Yeah, CRS, I think so it's before EGB. You see 280, so it is increasing temperature over its burner. And this is the catalyst element. 12.2 ppm. You can see over here 153, 12.3 ppm. So, so our SCR system is running. So okay. I will start for our AE ESCR. This is also same answer. Okay. Speed pump. Okay. You send it back to the service like if you want. This way we can see this solenoid. This is alpha soon going. Okay. So I will just cross check the all walls are open. Okay, all walls are open. Okay. AC was installed. The system is FCV flow control valves, filters. Most probably you will get blocked. This soon going was get blocked due to deposits because we don't use this system often. Only when we enter the ECA areas we use this. Okay. Okay. No pressure here up about. So okay. Okay. Here also same. See, bypass one and this one going there. Okay. Here we start. Okay. Auto condition is okay. See, if you're sorting out test, if you're sorting out pressure. Okay, to this, according to differentials, the pressure sets uh, uh, soon knowing will happen. I forgot to tell. And both AE and ME, same. Okay. 27, 20 meter. Not too much difference, but okay. Okay. You can see the walls have changed over. Number one and number two. Sorry, number one, number 21. Okay. So that's it. Oh, okay. So this much is there in the system. Okay, we'll discuss someday. Okay, so most of the system, general common system, we have discussed. Okay, guys. So we'll end this with this. We'll end this. Thank you very much for watching and supporting me. Thank you.